I know, Tyler said GT6, didn't it? It's not here yet. I have gone and grabbed some bits from it to get started on. Wanted to work on the gearbox because I thought all the bits of it were loose. Turns out they're not, so I've not got that. But I got a box of engine ancillaries and lights and things like that, so I'm going to be getting on looking at those. So let's dig through the rusty junk and see what we can make of it. Okay, so this is what we got. That's mostly lights, some of them. That's going in the bin. Bits of wiring, nothing particularly interesting in that. Well, useful, but not yet. Here, this is what I want to look at. So, I have just done a video on horns, so I'm not going to, unless there's something particularly exciting goes on there, particularly different, I won't film them. What I'm going to start on are the alternator, but what we'll look at now is the distributor. Now, it doesn't move at the moment, so the first job is going to be trying to get that to happen. Now, the Delcos were shipped with sintered iron bearings, so I suspect what we've got is a bit of rust between the steel shaft and the iron bearings. So, first things first, I'm going to take some of the top out so I can actually get some penetrating oil down towards where the bearings sit, and hopefully can free it off. And then after that, see what we can do. That was what was throwing me. I didn't realise this was a plate that moves on a base. So this is the thing this was actually held in by the screws that hold the vacuum advance unit and one extra. So I'm just going to get some penetrating oil down here and hope. Right, so that has actually freed up quite nicely. Good. I'm still wondering if I should take it apart though, because this O-ring is very hard, and also I'm not sure that this should move quite that much. I should have a bit of research and I think about that. Okay, so with a bit of penetrating oil, this freed off fine. Problem is that movement. I think that should be it's in the thousandths of an inch range. It's supposed to be, so that is very clearly not. So I started looking at spares for these. There's a thrust washer on the kind of shaft that goes to the middle, somewhere up here, and one somewhere down here. These are apparently no longer available, and there's various other spares that if you look to buy, I want to buy that thing, you can't get, including the pin that holds this drive dog onto the shaft, this plug here, and so on. I've also looked for, this wasn't really my preferred option for this car, but I also looked for, can someone rebuild it for me? Now there's a very well-known Lucas distributor specialist in the UK, but no one seems to touch the AC Delcos that I found. Anyway, so obviously I need, this is not right, so I may need some thrust washers. It also would have been nice to know how the advanced mechanism was working. So I've got two potential, or a double part solution. I've got a couple of pretty scabby looking distributors. I think these are Spitfire versions, shouldn't matter. Between the two of them, we should be able to get the washers. What this also gives me is the chance to tear one apart that is already pretty knackered. So if I break anything, I probably don't care. The other part is, assuming we can get enough bits out of those two to get everything back in a reasonable looking shape, how do I know that it's actually going to work as intended? So I found an article from a Corvette rebuilder magazine that described making a distributor test stand. So that's why I'm going to do that. It's pretty interesting because it's not. It's again it's a really quite a simple mechanism. All this stand is a heater motor that spins a distributor, and that's connected up to a conventional ignition circuit. So we've got a coil and obviously the distributor, and then the plug leads from the cap are just grounded. But motor spins the distributor. We've got the coil charging and discharging as it does on the car, which means you can use a standard timing light to, well, it'll flash in as it would if you were running the engine. Put some sort of disc that spins with the distributor shaft, then we can mark that with gradated, so it represents the degrees of the advance or retard, and measure that with the timing light. The other thing we need to know is simulated engine RPM, and that can be done with a rev counter, which I've got. Things I've had to buy, something to drive this dog that engages with the drive off the camshaft normally. And what I've got for that is it's the equivalent part from an A series engine, Austin A series, which is a longer shaft and has a gear lower down. So what I think I'm going to have to do there is I'm going to cut that gear off, turn down the shaft, and that'll be my drive, because it fits. These are the same as the Lucas 25 and 45 Ds that we used on the A series as well. And I bought a speed controller for the motor, just a little, cheap circuit off eBay. Anyway, there's enough talking. I'm going to go cut some wood to form the kind of frame of the stand, and we'll see how this goes. Well, I've changed my mind about the order of doing things. I kind of figured out, with what I've got lying around, somewhere on here, I'm going to have to mount a circle, which I'm going to try using this old CD. I'm also going to have a bush for it to run in, and this is an old pilot bush from a gearbox, which is too worn to run on the gearbox, but I should be able to machine this down to fit nicely in it. And then I've got to be able to connect to the bottom of this to actually turn it. Yeah, so this diameter here is too small for the bushing I have available. So that means I'm going to have to use this section, including the geared section, for bush and a disc mount and something to drive from. Now I'm going to have to also get this into the chuck of the lathe. It means I'm going to start off and grind off the gear, get it in the lathe and try and turn myself surface for things to ride on here. Anyway, I'm going to start on this because I've often not been very successful getting steel to turn on my mini lathe, so I have to see. That's going to be it. If that doesn't work, I'm not going any further. Well, this is sort of worked. I've never managed to get a decent finish on steel really on the mini lathe. I guess there's just, whatever I'm doing, I think there's too much flex in it, and I can't really manage to cut well and then finish it up. Anyway, I think for the purposes of how much this is going to run, this will do. And because of how much I've struggled to cut this, I'm not going to try and turn down to whatever, it's about 1/4 of an inch, the diameter of the motor spindle. So I'm going to see if I can get something either drilled and tapped into the end, or just a bit of rod welded in there to be my drive. So while looking for a 6mm drill bit, because I'd found a 6mm tap, I found a broken 5mm drill bit, and that was the right size. So that's my drive spindle. Next bit I've got to make is something to let me fix this on here. So I'm probably going to go and turn something out of Delrin that's going to be able to fix to this, to the CD, and then have a little grub screw that will grip onto the shaft so they spin together. So made a bit of progress. Now myself a little kind of top hat bushing. And that will go on, and I'll be screwing with some tiny little screws through into the Delrin. Hold that together. Eventually I'm going to make and print a degree wheel to go onto the CD. Then this will go from there, all the way up. And this is going to be the assembly that drives the distributor and allows us to actually take the measurements. So the next step I think is going to be to get that CD, so measurement disc and its bush put together, and then also some little grub screw in the side of here to hold it fast against the shaft. And then I'm going to be building the frame, sort of something like this. Okay, so having a brief interlude. So I've been in the woodwork workshop starting to build a stand for all of this. Then I thought I'd best check the motor. So this is a Delaney Galley Herald heater motor that I repaired to destruction some time ago, and have managed to put back together using some bits from another broken Smith's motor, which is slightly different, but there was enough commonality that I was able to make this work. And I just tested it because the DC motors I've played with mostly have been things like electric cars or Hornby trains, and they're all quite simplistic. They are permanent magnet motors and will spin in either direction if you change the polarity of the input voltage. Now I just did this on this motor, and well, it kept spinning in the same direction. So I took it apart again, and I realised it's not a permanent magnet motor, and I think this is what's going on. So what I think is happening is we induce a magnetic field in the armature, and we also induce a magnetic field in the outer coils, and these are always opposite and in the same direction because of this is wired. So I think what I'm going to be able to do, is change the direction in which the brushes and the power are wired to the outer coils. So that's going to reverse the direction of everything and should allow it to spin anti-clockwise, which is what we need for simulating, or what we need for driving a distributor. Yeah, I'm going to do that, and pretty sure that's going to solve that particular problem. Let's see if my vague memories of electronics theory are correct. Okay, it's possible that this is not going to do brush wear any good, because they're usually designed to go in one direction, and they'll wear prematurely if they go in the other. But the amount this is going to be run, that's no problem. If brushes wear out, I can replace the brushes. It's not usable in a car anymore because I've damaged the end of the armature pinion. Okay, now I can crack on with the rest of this build. Right, so this is what the drive setup's going to look like. It's just a bit of fuel hose. The article I read is suggesting a silicone hose for more flexibility. You can always revisit that if this doesn't work. But I've got old non-ethanol proof fuel hose kicking around, so I'm going to give it a try. So I'm just getting an idea of length, because I've put together a base the motor's going to sit in. Then we need 2 levels, something to keep this in place, and something for the distributor to sit in. So here is the frame I've been building. The motor will sit in there. Got to have these 2 blocks screwed together. That's so I can drill a centred hole, but one will be at the top and one somewhere further down. topmost one is where the distributor is going to sit, and the middle one is going to be where the drive shaft part goes. As I said, these are screwed together at the moment because I'm going to drill one hole through the middle, and because I've got a wood lathe, what I'm going to do is drill. Well, I have a wood lathe and I don't have a bit of the right size to fit the distributor shaft, so I'm going to drill an overlarge hole through both, and then turn down some inserts that one will hold the bush for the drive shaft, and the other will be the right size for the distributor to sit inside of. If you don't have a lathe, you could do this with just buying some more drill bits. As in this case, we'd need odd-sized holes or non-matching sized holes. Probably drill a pilot all the way through, and then drill the small hole from one side and turn it over and drill the larger hole from the other side. Anyway, gonna get that hole drilled, the top cross piece mounted in this frame. Then I will probably have to do some turning to be able to make my inserts, and once they're made, I'll be able to figure out where the midpoint block can go. And then we're getting quite close to having this sort of whole thing constructed and can start to think about some electrics. And there we go. So this is just sat in place. It's a good tight fit, so it should be quite easy to align. And now I've got to make my adapters to go in here. That will be the right diameter to take distributor and the drive shaft onto the wood lathe. So I've dug through the pile of stuff that I'm not sure why I was keeping, but seems to have come in useful, and got out a bag of plug wires of unknown origin. Actually, I think these were originally on the Spitfire. I wanted red tape on them. So I got that marked up with the 6-cylinder cap. These are all going to reach here fine. I need to get my earthing plate set up, so basically we're setting up an ignition system here, but that just earths every time the plug fires rather than sparks. So they'll have something to clip onto there. King lead will reach the coil, which will sit just off the side of here. And to make my earthing plate, I am just going to take the screw tops off of a few spark plugs and find the right the right bolt, so I can just bolt them through a bit of steel and screw that on here. So yeah, I'm going to get going on that. Well, my camera battery died, but you get the idea. A plate with plug tops on that these will clip to. So what's left from the structure is wiring. So this needs to be earthed, the body distributor needs to be earthed. I need to wire in a tachometer. For the time being, I've got a 6-cylinder one that's from a Triumph 2000 or something like that. Because we're making an ignition circuit here, it can just be wired in as it would in the car. And yeah, I'll have to make some sort of pointer for the degree wheel too. It's taken me a while to get to this actually, because I got between the last shot you saw and now, that's when my Herald's engine came back, so I've jumped off the test stand and onto actually getting that built. And now I'm just spraying up some bits of trim. I've got a bit of time to have a play with this again. So this is a replacement motor control unit because the old one wasn't working. And it spins. So what's next for this is to get the distributor, well, a distributor built up so it has points in it. It's probably going to be a 4-cylinder one because I've got a couple of 4-cylinder ones. Pretty sure I've got points for a 4-cylinder one. Not sure about the 6. And they may even be the same set of points, probably. Anyway, once that's up and running and actually functioning as an ignition circuit, we'll be able to see if the rev counter is going to work correctly, which it should, and then the timing light. If we've got all of those things, then it's ready to actually use. Although I might want to fix the motor down. Yeah, I'm already missing the screw that holds the condenser down. So I just got the last bits soldered on, so the spade connector will connect the distributor to the coil. Just turn it on and see what happens. What's happening is the distributor doesn't want to spin. Well, in principle it's working because I just shot myself off the coil. And the rev counter is twitching. This motor is not managing to turn the distributor. Not with all the whole mechanism in place. Now I'm gonna have to look for a better motor, higher torque motor. It's not in. Right, so pulling out the speedo drive gear, which is, you can see quite manky, and fiddling with the alignment a bit, I got it to run. yeah, so in principle everything's going to work. Timing light was firing, speed, the rev counter is working, so the coil, points, everything, the sort of ignition system is working well enough that this is feasible. But that motor is not going to cut it. So it's heating up. It's obviously struggling to drive the mechanism. I'm going to need to find something else. But it's progress. So I have been a bit back and forth on this, but I did eventually decide to buy another motor. So I figured something more modern is going to be a bit stronger than the Herald one. So this is from a 2001 Proton Wira, and I've never heard of one of those. And when I looked up some pictures, I've never seen one of those either. Probably explains why it was cheap. Anyway, I've tested it, it runs. It is directional. It's even marked, so there's positive here goes one direction, positive here goes the other. So I'm going to get this motor taken out, this one swapped in. It looks like it should just drop in. Then there's I think I just want a pointer. It should be good to go. Okay, so this is now set up and ready to test. Well, I have tested it, it spins. Should do what you need. So, and because in the course of working on the Herald just recently, I have gone and bought a dial back timing light. I don't need to do any thinking or corrections about using a 6-cylinder rev calculator with a 4-cylinder tacho, which we're going to test with, or figuring out crankshaft versus distributed degrees. So, as a test of this piece of equipment, we're going to measure and plot the advance curve of this Delco distributor. It's a D200 and something. It's a Spitfire-ish, Spitfire 1 to 4, somewhere one of those. I can't just go straight to testing the GT6 one because it's got a lot of play in, well, I think both laterally in the shaft and kind of up and down. So the thrust washers that stop the shaft moving up and down are worn as well. However, this one feels okay, except for being really, really disgusting, as you've seen. However, it's turning fine, and let's just see what it gives. And we'll be able to compare it with the manual specs and see where we are. So the idea is you run the distributor up to a certain number of RPM, working crankshaft RPM, and measure the mechanical advance. And that the revolutions, crankshaft revolutions versus the mechanical advance is the piece of information that we need to know to be able to determine what the actual advance curve is. Now, I will be able to also measure how the vacuum unit works on these. I don't have a vacuum pump, and anyway, I'm very surprised if this one works. Whatever, let's test the mechanical advance, or let's test the machine. Alright, so I've done a lot more messing around. I've fished out the distributor that came with my Spitfire, and out of the 3, I've cobbled together one where the advance is actually working. I didn't really want to use this one because it is really worn. I mean, you can very easily feel play in it. But for the purposes of checking that we're going to get a sensible result, this is going to work. I may probably going to cut out me fiddling around with trying to make a distributor for test purposes, because the point of this video is to make and check this stand, not to watch me faff around with knackered old dizzies. Anyway, let's check it, let's do some measurements. So the first thing to do is going to be to find the 0 point, which has got to be below around about 500 RPM, crankshaft RPM. So what I'm doing here to start with is running the machine at about 500 RPM and noting the value on the degree wheel that's showing at the pointer when the timing light is firing. It doesn't matter what this is, we just need to know that number because that's the 0 point. That's where we've got no advance. Then I'm running the machine all the way up to high RPM, as fast as it will go, in the 5,000, 6,500, and then I'm adjusting the advanced setting on the timing light until that 0 point lines up with the pointer again. And at that point I can record the RPM value and the advance value, and that's 1 point on our advance curve. Then I just step down gradually, decreasing the RPM and taking that same measurement, and that's what we plot to make up the advance curve of the distributor. And this is what that looks like. So here we've got the spec from the Spitfire Mark III workshop manual, and I've plotted the minimum and maximum advance that's expected or specified. Those are the blue with square points and the red with diamond shaped points. So they give us the range into which the curve is supposed to fall. And the green with the triangular points is what I've measured. And you can see it actually falls within those ranges, which is great. It's a little bit low at full advance. Anyway, for the purposes of test, this worked, and the advanced mechanism in the older distributor seems to be pretty good. Well, I know this thing's a little bit Heath Robinson looking, but it has worked. Once I'd actually used the correct set of data to compare with, having started off looking at the Spitfire Mark III US version distributor, which apparently has a much, for the emission control equipment, had a much higher total advance, which I actually know how that's supposed to work. But once I plotted against the curves that correspond to the UK spec distributor, this is quite a worn dizzy, but it looked reasonable. So that kind of confirmed this does work. I am happy that I'm going to be able to use it to check how the GT6 distributor performs once I've taken it apart and put it back together again. Because I'm hoping to be able to reuse the internals, but it does need to be disassembled because there's too much end flow on the drive shaft. Anyway, hopefully this has been interesting, and you can it shows you can actually reproduce one of them Sun distributor machines using mostly junk. So the only things I've bought, so I did buy the timing light for a different purpose, but I would definitely recommend that because it made kind of reading a whole lot easier. I did buy a replacement motor and the control circuit for the motor, but otherwise with stuff lying around the garage, so and that was pretty good. Anyway, hopefully this has shown you it's perfectly DIYable if you want to examine or play with advanced curves on Dizzy. And for now, thanks for watching, thanks for commenting, thanks for subscribing, and see you next time.